Okay, here's another problem that we need to review. If you have my handout notes, it's not very clear what I'm looking for here. So let me just tell you, is I'm looking for the voltage that's across each single component, R1 and R2 and R3. So what I've done here is that I've given you the voltage of VA, VB, VC, and VD, and that's in reference to ground. So the voltage at A is across all three resistors. The voltage at B is across the bottom two resistors. The voltage at C is going to be R3. The voltage at D is ground, which should be 0 volts. So these are my voltage drops. So this is all the voltage. As I move towards ground, my voltage becomes less. So I've given you some simple calculations to find out what those values would be. The voltage of R1 is the voltage of A minus the voltage of B. So I've taken those actual values, 10 volts minus 8.37, and I've come up with this 1.63 volts. The voltage on 2 is voltage of B minus C, so 8.37 minus 4.98, that's going to be 3.39 volts. And finally on R3, the voltage of C minus D is this 4.98 minus 0 volts, gives me a total of 4.98 volts. So if I add these three values up, this should be the value of my given source voltage, which is going to be 10 volts. You'll see this again on the test.